What's up, everyone? Welcome back. Patrick here, moving on to the next example on the Unit 1 Advanced Functions test. This one is dealing with inverses. As usual, I recommend pausing the video, try the question yourself. We've done lots of questions on inverses in the lecture videos. Hopefully you have watched those, so hopefully you're fairly comfortable with how they work. Try the question yourself and see if you maybe need to go back and review the process a little bit. But hopefully not. Hopefully you get the same solution that I am going to get. So in this particular question, we are given a quadratic. So we got f of x equals negative x squared minus 4x minus 7. Got to find the inverse of it, and then also the domain and range of the inverse. Now, unfortunately, this quadratic here, it's given in standard form. And if you remember, I've mentioned this before many times, if you're going to find the inverse of a quadratic, it has to be in vertex form, right? Because if we switch up the x and the y values now, if we put the y values here, it's going to be really hard to isolate for those y values, right? So we want to change this to vertex form first. So then when we switch the x and y values, there's going to be only one y value to isolate for. So we got to complete the square on this. So let's do that quickly. Take out a negative from the first two. Got the minus 7 on the outside. Then we're going to take the 4. Let me do it down here. I'm going to divide it by 2 and then square it, which is going to be 2 squared, which is 4. So then what we got to do is we got to take that 4 and we got to basically write it over here. So it's going to be like plus 4 minus 4, right? And then we got the minus 7. Now this negative 4 we got to take outside of the bracket. When we take it outside of the bracket, we've got to divide by what's in, or multiply by what's in front of the bracket, which is negative 1, right? So next line is going to be negative x squared plus 4x plus 4. Now taking the negative 4 out, multiplying it by negative 1, that's going to give us positive 4. And I got a minus 7 right here. Now this, the reason why we do this process over here is because this is going to end up being always a perfect square trinomial. And in this case, it's going to be x plus 2 squared, right? This number here, it's always going to be the square root of this number, or it's going to be half of this number, and then this sign is always going to be the same as that sign right there. So if this was x squared minus 4x plus 4, this would end up being x minus 2 squared, right? But that was a positive, so we're all good. And then this 4 minus 7, that gives us negative 3, like that, right? So at this point, what we did was we took this standard form quadratic and converted it to, we converted it to a vertex form. So I'm going to take this and I'm going to bring it up here just to give myself some room for the next algebra that is coming up. So, and then also let's erase this. So now notice that instead of there being 2 x values in this quadratic, right, there's only 1 x value now. And now it's much easier to isolate when we switch up that x and y, interchange that x and y, because now we're going to be finding the inverse. Got to isolate for that new y value. So what would we do? Well, we would bring the negative 3 over, so we'd have x plus 3. Got a negative y plus 2 squared, like that, and then divide both sides by negative 1. Okay, so we'd end up with basically y plus 2 squared. So I'm actually going to write it on this side. We'll have y plus 2 squared equals x plus 3 over negative 1. To make it look a little nicer, I'm going to bring the negative 1 up. So I'll just put that like on outside, on an outside bracket. You don't have to. You keep the negative 1 like that. I'm not sure how picky your teacher is. I'm just going to bring that negative up, and then, so if this was like a negative 2, let's say, in the denominator, I would just bring the negative up, put it outside the brackets, but the 2 would stay down there, right? But I brought the negative up. There was only a 1 down here. Didn't have to write the 1. So we got this. Now we got to get rid of this exponent, so we would square root both sides. So we'd have y plus 2 equals the square root of negative x plus 3, like that. And then this is technically plus and minus when we square root that. Bring the 2 over, So we'd have plus or minus root negative x plus 3, and then we got a minus 2, like that, right? So that right there ends up being the inverse of this quadratic that we were given. So first we have to convert the quadratic to vertex form, and then we were able to get the inverse pretty smoothly after that. All right, so that right there ends up being your final answer for part A. Now, what they're asking for in part B is what is the domain and range of this. Yo, what's up? Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit that have video solutions. Number two, if you feel like you need tutoring at any point, hit me up. I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Inverse going to be. Now, what I would do personally is I would actually, since we have the quadratic in vertex form, it's very easy to get the domain and range of the original quadratic, and then we could just interchange it for the inverse, right? So if we took this quadratic and drew like a very rough graph, where's the vertex going to be? It's going to be at -2, -3, which is over here. And because we have a -1 as an a value, we know that that quadratic is opening down like that. So this vertex here is at -2, -3. Now remember, this is the original function, right? This is not the inverse. This is f of x. This is this function right here. So what's the domain of f of x? Well, it's XER. And then what's the range? It's YER, but y is less than or equal to -3. Well, because we have the domain and range of the function, we know that the inverse, the domain and range, is just going to be the domain and range from the original function interchanged. So we know that the domain of the inverse is going to be XER. X is less than or equal to -3, right? Just interchange this range to this domain, and then the range of the inverse is going to be the domain of the function. So it's just going to be YER, like that. Okay, and if you wanted to graph this, what you could do, basically the inverse of a regular parabola is always going to be a sideways parabola. And what's easy to do is the vertex of the original function f of x is going to be the vertex of the sideways parabola, the inverse. So actually, the interchange vertex, so if the vertex here is -2, -3, then the vertex on the inverse is going to be -3, -2, which is going to be like over here, let's say. And because we know the domain is less than or equal to 3, we know the sideways parabola is going to look something like that, right? So this coordinate, this x value of this vertex is going to be -3. The y value is going to be -2, right? It's going to be interchanged here. Here, the x value is -2, and the y value is -3. For the sideways parabola, for the inverse, it's going to be that coordinate interchanged, right? So that's how the graph is going to look. Now, they weren't asking for the graph, but I just wanted to show you a visual of how it looks like so you could see how this domain and range come about. So instead of looking at this equation for the inverse to get the domain and range, because we got the vertex form of the function, easier to get the domain and range of that, and then just interchange the domain and range in order to get the inverse domain and range. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.